Hello, statistical scholars. Welcome to a video on how to do confidence intervals for proportions. So I'm going to show you how to do this on the calculator today. Um, and I've got two examples I'm going to walk you through on how to glean some information off your calculator. So a candidate in a two-person election commissions a poll to determine who is ahead. The pollster randomly chooses 500 registered voters and determines that 250 of the 500 favor the candidate. We're going to calculate the mean and the standard deviation for the sampling distribution. So I've already done a little bit of work here. I've written that, oh, my mean, that's just going to be my proportion, you know. So I need to calculate that first, and then remember the sampling distributions going to require a little bit more work too. So first I want to calculate my actual p hat, my true proportion that I'm estimating. So that's 260 out of 500, and that's about 52%. That tells me that 52% of the people polled were in favor. That doesn't tell me that everyone was in favor, which is what we're trying to estimate with a confidence interval. So next I need to calculate the standard deviation. So to do that I need to do the square root of, and I'm going to use parentheses here for the I did not want that kind of parentheses. Sorry about that. For the numerator and not put in the fractions, I'm just going to use the decimals in this case. So I need P times Q, which is 1 minus P, which is 0.48. Close my parentheses. Or hit the wrong button again because I'm having a good time with this. And then divide by, sarcasm probably doesn't come across very well. Divide by 500 and hit enter. Yay! Okay, there is my estimate for the standard deviation of the sampling distribution. 4841. Okay, and I'm writing all these on here because it didn't terminate. If you have a decimal that terminates like 0.52, you should not be rounding it. It stopped. There's no reason to round it. But when you have something that goes on forever like this, that's when you probably should round. I'm not going to round because I want to make this as accurate as possible. So let's go ahead and hit the stat key and go over to the test menu. In here you're going to see lots of tests, some of which we will use in the next video for doing actual tests. But for now we want the one prop z interval. We're going to go ahead and hit enter here. So it asks you for, hey, how many successes did you get? Well, I had 52. Then you ask you for, or 52, sorry, I had 260. And how many people did I ask? Well, I asked 500. And what confidence level do I want? I want 95%. All right, looking good in the neighborhood. Let's go ahead and hit enter. There we go. It gives us our P, gives us our sample size, and more importantly, it gives us your interval. So I'm going to go ahead and put that in part B, comma. I like to put a little space here so it's clear. Oh, probably should put a 0 too, so it's a little easier to read. And now I didn't ask for this in this question, but if you were to interpret this interval, you would say, oh, the entire population of registered voters, because that's what this would estimate well, your sample has to represent your population that you're trying to represent, would be between, 47.6% and 56% people favor the candidate. So as you look at this, you should be like, oh, well, there is a chance he could lose because that's under half, depending on your voting rules. Alrighty, let's take a look at this next one. So suppose instead I want to do a 90% confidence interval of likely voters. So we're looking at approval rating in this one, which is slightly different. So let's go ahead and hit stat again. We're going to arrow over to tests, and we want the one prop z interval, which is near the bottom. All right, and here I have 141 people out of 300. And instead of 95, I want 90%. Now, you could just put 0.9 here. It would still work just the same, but that's what we're going to do for now. Let's go ahead and hit enter. And there we go. I have my confidence interval. So 0.4226, comma, 0.5174. And then the next thing they ask is for the margin of error. Now you might be thinking, that's not where I wanted to put that. That the margin of error is something I'm going to have to go calculate my z-score and use the formula and whatnot to be able to figure out what the margin of error would be. But in truth, one thing you should keep in mind, I'm going to enter this down so I can use it later, is that when you do your confidence interval, it's always estimate, plus or minus the margin of error. That means that if I know my estimate and I know one end of my confidence interval or the other, I can actually find the margin of error. Because if you think about it, your center estimate, your p hat, is the middle of the interval. Or I took the estimate and I added the margin of error to get the upper one. So if I subtract the estimate, I get the margin of error. So instead I'm going to do 0.5174 minus 0.47, and that will give me the margin of error. So another way you can think about it is, well, what's really the margin of error? It's the upper end of the confidence interval minus the estimate. And that will always give me this, which is kind of fun. Or if you want, you can do the lower end of the estimate, the lower end of the confidence interval, and then subtract the estimate, and that'll give you the negative of the margin of error. Oh, I was at a loss for words for a second. Couldn't think of what it's called. All right, let's go ahead and do that. So I need 0.5174 minus my p hat, which is 0.47. And I get that my margin of error was about 4%, almost 5%. Lovely. Notice, no rounding, because it terminates. All right, so that's how you can quickly and easily find the margin of error should you need it. That's all for now. See you soon.